Hello, everybody, and welcome to Pisa Presents with Titanoboa and other giant fossil snakes. Now, I love snakes, absolutely love them. I've probably loved snakes ever since my cousins Brian and Gary decided to mess with me by letting me use my great uncle's outhouse, without coincidentally mentioning that it had a large resident snake, only to have said resident snake pop up its head and kind of like greet me mid seat. Now, my cousins probably thought that I would get freaked out by this, but instead, my little 3 or 4 year old self was like, "Can I keep it?" And I basically yoinked this thing out of the outhouse seat and then came running out with it and scared the bejesus out of him. But I don't know, my uncle thought it was hysterical. So now, mind you, that was just probably one of these, I'm pretty sure. Granted, it's been quite some time, but still. It was probably just an eastern rat snake. Now, while no pushover in size at about like maybe 3.5 foot long or so, it's still quite small in comparison to several species of early fossil snakes. So let's look into the evolution of our serpentine friends as well as some of their bigger representatives, potentially some of the larger animals ever to be on Earth. Now, the problem, though, with determining the evolutionary origins of snakes is, as you can see from the skeletons there, is that they're very delicate. Gracile is the term, which means that it's hard for any remains to survive the strenuous process of fossilization. Fossilization is very, very hard on any skeleton, really, especially one that's just very well put together and tough and just very, very thick and dense. So, something that's very, very small and delicate, like a snake skeleton, well, it's very hard on it. So, we just don't have as many snake skeletons as one might expect for a group of animals that's just so famous and around throughout history. And truth is, we aren't really sure how snakes evolved, but we have two ideas. The first idea is that they first appeared from reptiles in the sea and that they then came onto land. The other idea is that they were once burrowing reptiles called fossorial reptiles. Of course, we have plenty of fossorial snakes today, in addition to aquatic ones, and those on land. Now, that was just merely due to diversification after their original evolution. How that original evolution came about is just something that's up to a great deal of debate nowadays. Some paleontologists theorize that snakes evolved their ears and eyelids as ways to keep dirt out while burrowing or to act as a sort of shield while swimming. Those early snakes were perhaps distant relatives of mosasaurs, as a guess based off of morphology. Very, very distant guess, perhaps. The camp is fairly evenly divided on that, so really we don't know from where they came. Perhaps it was a mixture of both camps, snakes evolving independently from both the water and the sea. The water and the land, rather. Now, Eophis underwoodi from England lived approximately 167 million years ago during the Middle Jurassic period. It is often credited as being the first snake that we know of. For many years, paleontologists believed that snakes evolved in the Cretaceous, but we now have Eophis and some other early species to push back the clock. And as these early serpents were around by the Jurassic, that means that the actual ancestors of snakes or their evolutionary processes that created them happened much earlier, some thinking in the Jurassic or Triassic rather, or even earlier than that. And snakes are, of course, reptiles, meaning that they are cold blooded. That's very important later. Snakes are modern snakes, actually, are members of the clade Ophidia and of the suborder Serpentes. Fossil snakes can be slightly different. For example, we have other groups going back into the past, such as many families in genus, with two ones of note being the family Metsoideae. Now, that may or may not be members of the suborder Serpentes. There's some debate about that. From about 100 million years ago, that's during the time of Gondwana. There are also the Boidae from about 30, about maybe 20 perhaps, to 20 million years later. These, also known as the boids, or boids, are famous today as species such as the anaconda or the boa constrictor. And I mean, come on, isn't that just adorable right there, that pretty apple green? Many species of boids actually have vestigial limbs while still in their shell, and in 2016, two studies reported that limb loss in modern snakes is associated with DNA mutations in what was named the sonic hedgehog gene. Yes, that is the actual name of the gene. So you may be wondering, really, how did snakes get so big? I mean, Titanoboa is not the only large fossil snake, but still it's pretty darn honkin' big. So the answer comes to us right in the Paleocene, the time right after the extinction of the dinosaurs. In many places, it was a time of great ecological diversity and change, with many regions becoming humid, moist swamps. Now, being so warm, cold blooded species like snakes were able to maintain a constant, snug body temperature. And with no large dinosaurs as competition, they were able to get very large potentially as a result. And yes, they did sometimes interact with dinosaurs, with the remains of a titanosaur being found in the stomach of one of these snakes right here, which was about 10 to 12 foot long or so from the Cretaceous of India. And here we have a brief look at several large snake species compared to an ordinary human, or at least compared to an ordinary version of me who would have hung around by the lot of them and not be running away screaming. So let's have a look at some of these fellows right here. Now, first off is Titanoboa. We're going to take a peek at some of its history. So it was actually found in, which I think is pretty cool, a coal mine. So, miners in this mine, the Cerrejón, were aware of these very large fossils as far back as 1990 that we know of, possibly a bit earlier than that. Now, many of these fossils were of large crocodiles, as befitting the swampy environment at the time that the mine's coal was laid down. I mean, if you think about it, it makes a lot of sense, right? So in 2003, some sources say 2002, a large mass of what was then unique looking bones were found, but they were immediately classified as crocodilian. So they just kind of figured that, well, we have all these crocodiles around here and what have you, and so it kind of got lumped in with the rest of these crocodile fossils. And here is actually one of them. So in 2007, the fossils were sent to the Florida Museum of Natural History, where students and other individuals were taking an extra look at some of these 186 bones and noticed their similarity to snakes. Now, with the first look and some other groups immediately afterwards taking a couple of more peeks too, they were able to find remains from up to 30 individuals at this coal mine. And so, because once they started noticing, hey, these aren't crocodiles, these are snakes. And so they started going back and digging up more and more and more. And they realized just how prolific these animals were in the area. I mean, if you think about it, to find 30 different specimens of just the same fossil immediately in the area, something just that big, it shows you how prolific Titanoboa was. And so these findings were published in 2009, naming our very new friend Titanoboa cerrejonensis. So, found again in Colombia from about 60 to 58 million years ago, and they are boids. And again, absolutely adorable. So, how big was Titanoboa? Estimates vary, but any one of them really calculated roughly by examining the proportions of the size differences between key points on the vertebra and comparing them to modern boids. So basically, what paleontologists do, because if you look at some of the estimates on basically the size ranges of Titanoboa, and yes, they're just that, they're estimates because we obviously do not have the whole animal. Some of these size ranges can be, well, ranging. They can vary quite a bit. And that's because what they do is that they'll compare the gaps more or less in between one vertebra and the next, And then they'll compare that gap between how it is between, say, the modern anaconda down below, right there. So they're trying to make analogies between the extinct animal of the past and then the modern day animal. So they're thinking that Titanoboa was anywhere from about 42 foot long and up, with some thinking it's over 50 foot long. I've seen a couple of people think it's in the high 50s, but that I do think is a bit of a stretch, no pun intended. Usually the size is capped off at about 47 or even 49 foot. Now, weighing at about 2,000 to 2,500 pounds, you can compare that to the anaconda again down below at about 500 pounds and 28 foot long. Again, still no pushover, but that's just to give you a comparison to just how big Titanoboa was. And a very rare thing about Titanoboa is that we have several skulls intact. The skull is not too much like other boids. They had teeth like fishing hooks, which meant that they had much more of an aquatic lifestyle. While they did not basically swim more or less, they probably spent more time by the shore and ate more of a sort of like a fish sort of diet. And they had upwards of perhaps a 400 pounds per square inch constriction and maybe even ate crocodiles, of course, because of the other animals that were in the coal mine that they were with. So obviously, fish did not probably satisfy an animal that size. Now, wait though, hold on. The crown of the king of the serpents may not be settled quite yet. Vasuki Indicus has just entered the chat. Now, Vasuki here was discovered in India in 2005. Now, they're the prior family that we mentioned, the Metsozoidae. Now, like Titanoboa, though, they were also found in a mine. And they were named very fittingly, I think, for a serpent king deity from the Hindu faith. And they were possibly over 50 foot long. Estimates vary quite much depending on what ratio one uses to estimate the size of them. They lived about 47 million years ago, and Vasuki may have perhaps had a larger body, but it was more slender than Titanoboa. It was about the size of a thick human thigh. It could have weighed just over 1 ton, with Titanoboa weighing about maybe 1.25 tons ballpark, just to give you an idea. And here is another early snake, Paleophis. So this came from several different localities. You can see the time range right there. They're marine only snakes, so just in the water, up to 40 foot long. And whenever I see reconstructions of these, they just remind me of the sandworms in Beetlejuice, but that's just me. And then here is another one, not quite as big, but still from Egypt, and then in the Eocene. And then we are going to wind up with another one from Australia, 10 to 20 foot long, the one and only Wanambi. So thank you very much for joining us this weekend, folks, and I hope you had a lovely time joining us in the wide and wonderful world of our friends, the snakes.